So this video lesson is going to be over scientific notation. So scientific notation is a different way to express a number or write uh, a number that would either be a little too long or really too small. So for example, just bring this out. So if we wanted to write 94 million, which is how many miles the Earth is from the sun. Oh, cool little sun there. So 94 million miles the Earth is from the sun. So scientific notation is a different way to express that number. So this number right here, what we're used to is what's called standard notation. So they give you an example here of 1,657,000 and 0.045 or 45 thousandths. So what they do is it's all about moving the decimal point to express it as a 10 to an exponent. So as you can see, for example, so scientific notation, you can easily plug that into the calculator, and depending on the type of calculator, it should be able to show up like this. But if not, because sometimes the calculator will just express it as scientific notation versus standard notation. So we'll go ahead and learn how to do it by hand. So the rules to scientific notation is that whenever you convert it from standard to scientific, notice how it says digit before the decimal has to be any number 1 through 9. So that means whenever you move the decimal from standard notation, so let's say we have 1,657,000, decimal is going to go right there after the whole number, so that's a whole number. So that means if we were to move it, we can only move the decimal to where there's only one digit expressed on the left side of the decimal point. So if you see anything like this is scientific notation. If you see something like 12.3 times 10 to the fourth, and it's asking you, is this scientific notation? It would be no, it's not scientific notation because there's two digits before the decimal. In this case, it's 1 and 2. It would have to only be one digit. All right, so the exponent. So about the exponent shows how many times you move the decimal. So remember, our goal is to move the decimal to where only one digit is expressed before the decimal. So if we're going to do 1,657,000, we would move it, go from here to here, one place value 2, 3, 4, 5, 6. We would get 1.657, which is what they got right here, 1.657 times to the power of 6. So since we move the decimal 6 times over to the left, to express this large number, we put the exponent to the 6th power. In this one, for example, so they're expressing a small number, so it's moving 1, 2. Remember, we just want one number before the decimal, any number 1 through 9. So it'd be 4.5, which is what they have, times x to the negative 2. And since it's to the negative, that means it's expressing a small number. So whenever you're expressing a really, really small number where there's numbers after the decimal point, which indicates less than 1, if it's less than 1, then it's going to be to the negative exponent. All right, so let's take a look at some of these. Now let's go ahead and do our sun example. So we have 94 million. So that means we're going to identify our decimal. So that means we put 0.0, that makes it easier. So remember, our goal is to move the decimal to where the digit is one decimal after, or where there's one number any number 1 through 9 before the decimal. So we need to move this decimal from here to here. So we're going to move this 1, 2, 3, 4, 5, 6, 7 times. So that's 7 times we move. So that means our new number is going to be 9.4 times 10. Your base number is always 10. 10 to the, we move 7 place values, so it'll be 10 to the 7th power. This one is going to be positive because we are expressing a number greater than 1. So since it's a number greater than 1, 94 million is greater than 1. Hopefully we all agree with that. So it would be to the positive 7th power. So this would be scientific notation. And this, of course, is our what's called what we're normally used to, and that's our standard notation. All right, let's look at some others. All right, so we're given, this time we're given the scientific notation. So instead of going from standard to scientific, we're going from scientific to standard. So they say it's moving to the right. So it is going to move to the right because we have a positive exponent. So that means we need to express a number that's greater than 1. So we can't move to the left because if we move to the left any numbers, our number is going to be less than 1. But we can't do that because we have a positive exponent. So it has to be a number greater than 1. So we're going to move 4 units to the right to express a bigger number, bigger than 1. So we go 1, 2, 3, 4. Decimal goes there, fill in your zeros, and that's what they got here. So 12,300. It's a comma, by the way. Comma, so 12,300. So 12,300 is the same as 1.23 times 10 to the 4th power. All right, so here's another example. This time, this is in standard notation. So make sure you're able to identify a number. Standard notation, which is the numbers we're normally used to, and scientific notation. So scientific, standard. All right, so they want us to, is that a comma? I think that's a comma. So they want us to put it into scientific notation. So we're going to add a decimal to our whole number. Remember, we want there to only be one number before the decimal. So we're going to move it 1, 2, 3. So our 4 is our only number. That's good. That's what we want. So we would get 4.5 times 10. 10 is always our base. And how many times did we move over? 1, 2, 3. So it'd be 10 to the 3rd power. Since we're expressing a number that's greater than 1, our exponent is going to be positive. Just like our exponent was positive here, so we were expressing a number greater than 1. All right, so let's take a look, get some more information on the negative exponent. So it says negative exponent means the standard notation is less than 1. Okay, yeah, so that's what I was saying. So greater than 1, you have positive exponent. Negative exponent means your number is less than 1. All right, so we have negative exponent here. So instead of going to the right, like up here, we're going to go to the left because that'll give us a number less than 1. And they already do it here for us. So we go 1, 2, 3, 4. And we end up with 0.00012, So this number right here is standard notation. This is scientific notation. All right, let's go over here. So this is standard, and it's a number less than 1, so that means our exponent is going to be negative. Let's see how many times we move over. Remember, our goal is there to be, up here, one number before the decimal, anywhere between 1 to 9. So that means we're going to put this, we want to move this decimal between the 4 and the 5. So that way the only number is 4 to the left of the decimal point. So we got 1, 2, 3. So we're left with 4.5 times our base of 10. How many times did we move over? 1, 2, 3. So it'd be to the negative 3rd power. You can always type this in on your calculator too and see what it says. Kind of double check your answer. So this will be that's your answer. All right, so I recommend you pause the video, try these on your own first, and then restart the video so that way you can check your work. All right, so we have standard. It's a number less than 1, so that means we're going to have a negative exponent. So when it's times 10, it's going to be times 10 to the negative some power. All right, so where do we want our decimal to go? Well, our decimal is we're going to want our decimal to go right here because we want one number to the left of our new decimal to be any number between 1 and 9. So it's going to be right after the 8. And we're going to move 1, 2, 3, 4 times. So we're going to express this as 8.34 times 10 to the 1, 2, 3, 4 to the -4. So since our standard notation is a number that's less than 1, our exponent is going to be negative. So keep that in mind. If you have a number, if your standard notation number is greater than 1, such as this one right here, so that means our exponent over here is going to be a positive number. All right, we're going backwards. So we have a positive exponent, so we want to express a number greater than 1. So that means we're definitely going to move to the right, so that way it gives us a new number greater than 1. And we go 3 times. So I'm going to go ahead and just write 533 over here. So that way I can get my, go ahead and move over. So we got 1, 2, 3. Got to fill in the 0 right here. So all I have to do is add a 0 over here. So 3 times. So we go 1, 2, 3. So that's our decimal. So remember, invisible math tells us we can add a 0, put a decimal 0. So that's invisible math. So this is our standard notation. This is our scientific notation. All right. So over here we have 5,610,000. Okay, so it's a number greater than 1, so we're going to have a positive exponent. So I'm going to go ahead and write times 10, and then we're going to have to the positive number. Let's go ahead and identify where our decimal goes right after the last number. So that's our whole, well, we're expressing a whole number with a decimal. Go ahead and add a 0 since that's kind of what we're used to. All right, so remember our goal is to get the decimal between, we want to get it here. So I'm going to go over 1, 2, 3, 4, 5, 6. So that means our exponent is going to be 6. Positive 6, since our standard notation is greater than 1. And what are we left with? We're left with 5.61. So 5.61. You always want to express those numbers. You just don't express any of the zeros. All right, let's go down here. All right, so now we have 1.98 times 10 to the -1. So it's a -1. That means we're expressing a number. We want to express the standard notation of less than 1. So we're not going to move to the right. We're going to move to the left 1 time. So we're left with 0.198. And that's it. We just move 1 time. So this is our standard notation and our scientific notation. So that's scientific notation.